Okay, we continue with numericals on wave theory or wave nature of light. Let's start with some very easy numericals. This is directly from the NCERT. Okay, let's start. The wavelength range of visible spectrum extends from 400 nanometers to 750 nanometers. Find frequency. So, what have they given us? They've given us wavelength, people. So, what is the wavelength of violet light given? 400 nanometers. How do I convert nanometers to meters? This will become 400 times 10 raised to minus 9 meters. And they've given the same for red light. How much is that, people? 750 nanometers. That becomes 750 into 10 raised to minus 9 meters. How do I find frequency? We know that wave velocity c is equal to nu times lambda. How much is c? 3 into 10 to power 8, that is equal to frequency is what we are looking for. And how much is the wavelength for violet light? 400 into 10 to power minus 9. Therefore, एकदम easy questions है ये. Nu will be 3 into 10 to power 8 upon 400 into 10 raised to power 9. To simplify this, can I say this is 3 into 10 to power 8 over 4 into 10 raised to minus 7. What we just did here is we wrote 400 as 4 into 10 to power 2. People, what is 3 by 4? 0.75. And 10 raised to minus 7 goes up, becomes, so 10 raised to 8 times 10 raised to 7. So the frequency of violet light that we get is how much? 0.75 into 10 to power 15. What was the unit? Anyone remembers the unit? Hertz. Can we similarly solve for red light? कैसे करेंगे? Again, C is equal to nu times lambda. Now we are finding for red light. C is same, 3 into 10 raised to 8. Frequency निकालनी है, and the wavelength for red light is given as 750 into 10 to power minus 9. The frequency of red light will be 3 into 10 raised to 8 upon 750 into 10 raised to minus 9, or 3 into 10 raised to 8 upon, वापस से 750 को I can write 7.5 into 10 raised to minus 7, that goes up, so 3 into 10 raised to 15 upon 7.5. इसको solve करेंगे तो I think we get 0.4 into, that is 30, yes, 10 raised to 15 hertz. Anyone who did not get this? Basic and direct substitution है. What about here, people? Frequency तो चलो you can find. They've given us wavelength. This wavelength is given in which unit? 5800 angstrom. What is the conversion for angstrom to meters? Excellent. 5800 into 10 raised to minus 10 meters. We have to find wave number. Anyone, what was the symbol for wave number? So what is the relation between nu bar and wavelength? 1 by lambda. So this is 1 by 5800 into 10 to power minus 10. and frequency के लिए what formula will we use? C is equal to nu times lambda, where C is 3 into 10 raised to 8 frequency into, and lambda is 5800 into 10 raised to minus 10. Easy peasy. चलो Chalo, let's continue, people. That was wave nature of light. We continue the next part that we have. What was the second part, people? Wave nature, and the other nature was particle nature. Now we start with particle nature of light. Now, in order to understand particle nature of light, we have to understand black body radiation and Planck's quantum theory. Okay. Now let's understand what is black body radiation first, and then we move on to Planck's quantum theory. Now, can you people tell me what is the color of the flame for a candle? Let's say the candle that we have at home. What's the color of the flame? It's red, orange, yellowish. वो flame है. Anyone who's tried to play with the flame? If you've not, please be careful. But we all have tried. I've tried to play with the flame, to catch the flame. Yes or no? No. We all have, LPG gas connection at home. उस पे gas पे खाना बनता है. What is the color of that flame? Bluish. Why don't we try to catch that flame? Let's say there's no one at home, and I keep a candle in front of you, and I keep the gas flame in front of you, and थोड़ा मस्ती करना है. Please don't do this at home. ठीक है, disclaimer, internet पे कोई देखेगा तो I'm not responsible. Please do not do this. So, when you try to catch the flame, कौन सा flame मस्ती कर रहे तो you'll try to catch candle. Will you try to catch that blue वाला flame? No, why? Sorry. Chemistry lecture में नहीं आएगा फिर. अच्छा. Left hand से to right hand से लिखती है ना. Try with left hand. Yes. Why, people? What tells you that you should not try to catch that blue flame? Because it is hotter. But what tells you that it's hotter? So intensity of light, when the intensity of light changes, it changes its dash, changes its color. It goes from red to blue. Or if I try to plot it from a Vibgyor perspective, that candle wala flame is of what color? ये range में है थोड़ा सा. अगर हम एक range देने की कोशिश करें, it's like somewhere over here. It's orange, reddish. And as the intensity of heat increases, it gets more hotter. It turns what color? ये range में आ जाता है वो. Yes or no? If you've observed, it actually also turns white, and then it turns blue, and that blue color is a really nice, pretty blue color. So when you're increasing the intensity of light, can someone tell me dash is increasing in terms of wavelength and frequency. As I'm increasing the intensity of light, I'm going from red to violet. What is increasing? Frequency is increasing and wavelength is, don't worry, I'll make you write all this, but वैसे बता रहा हूँ. So what is increasing? Intensity. As intensity increases, wavelength is decreasing and frequency is increasing. With me till here? Yes or no? Now till we had only the wave nature of light, scientists were trying to bring or find a relation between intensity and wavelength, but कुछ concrete value मिल नहीं रहा था. I repeat, they were trying to find the relation between intensity and wavelength. अब हमने यहाँ पे relation देख लिया. So if I try to plot a graph, I repeat, if I plot a graph of intensity on an axis and wavelength over here, this is intensity, and what do we have here, people? Wavelength. So understand what's really happening here. Let's say I start from like zero intensity. Obviously, if the intensity is zero, there is no wavelength. Now, if I increase the intensity, wavelength first increases. Actually, ulta bolna chahiye, but theek hai. It reaches a maximum value, and if you continue to increase the intensity, the plot looks something like this. With me till here? Okay. So it first increases, it reaches a maxima, and then what is happening? Intensity is decreasing as I keep on increasing the wavelength. और ये point को हम क्या बोलेंगे, people? We'll call this point as maxima. यहाँ पे there is some value, let's say I put it lambda 1, and the intensity is somewhat over here. Let's say I put the intensity at I1, and all this is, let's say, happening at a temperature T1. With me? Now as I increase the temperature, I repeat, as I increase the temperature, what's happening is wavelength गलत प्लॉट बना है. I'll थोड़ा सा decrease the size of the first plot. So let's say this is T1. This is lambda 1, and this is intensity I1. Then so here temperature T2 is greater than temperature T1. I repeat, as you increase the temperature, the maxima is shifting behind. Wavelength starts decreasing. Intensity भी बढ़ा है and wavelength decreases. This is I2. Do you see lambda 2 which is greater? Lambda 2 or lambda 1 which is greater? So as intensity increases, what is happening to wavelength? If I further increase the temperature, plot और पीछे जाएगा. Lambda will keep moving behind. And compare T3, T2, T1, which is greater? T3 is greater than T2 is greater than T1. So as you increase the temperature, the maxima of the wavelength keeps shifting behind, or wavelength कम होता जाता है. Now this couldn't be really explained by the wave nature of light. You had to understand the particle nature to really explain this. And what exactly? So whenever you heat a body, it will try to release as many radiations as possible. Till 10th standard ऐसा कुछ किया है क्या black body? Okay, now what exactly is a black body? So let's say I have एक ऐसा sphere coated inside with carbon black, and there's a very tiny gap here, and inside what we have coated is carbon. Now carbon absorbs almost, or black color absorbs 98% of heat radiation. So let's say if let's say this is light, so when it is incidented here, it will absorb 98% of that radiation and release 2%. It will reflect. That 2% which was reflected, which again get absorbed 98%. Are you getting that? So we say that hypothetically ये ऐसा structure है that is going to absorb all light radiation. This is called as a black body. So this phenomena was explained with the help of Planck's quantum theory. So सिर्फ headline लिखो. We'll first write the theory and then we will copy the diagram. नहीं, theory dictate कर लेता हूँ. We'll just write key points. Please write down. Hot body or hot objects emit electromagnetic radiations. Hot objects emit electromagnetic radiations over wide range of wavelengths. So what this means, people, the color of the flame that we see, it's because of the wavelength that the flame is emitting, and that wavelength falls in the visible range and we see that color. Okay. Next point. As the temperature is raised, a higher proportion of short wavelength is generated. A higher proportion of short wavelength is generated. Full stop. Continue. For example, when an iron rod is heated, when an iron rod is heated, it first turns red, and when heated further, the radiation emitted becomes white and then blue. The radiation becomes white and then blue. At very high temperatures. Next point. This means that the intensities of radiation, this means that the intensity of radiation of different wavelengths emitted by hot body, depends upon the temperature. Of different wavelengths emitted by hot body depends upon the temperature. Next point. An ideal body which emits and absorbs radiations of all frequencies uniformly, is called as black body radiation. Next point. At a given temperature, the intensity of radiation emitted increases with the increase in wavelength. And it reaches a maximum value. Increases with increase in wavelength. And it reaches a maximum value at a given wavelength. And then starts decreasing with further increase of wavelength. increase of wavelength. Now let's understand this point again. So at temperature T1, as wavelength increases, intensity increases, but as further wavelength increases, intensity starts to decrease at a particular temperature. If I increase the temperature, phenomena same, but the maxima shifts behind. Did you get that? Do you want me to explain that again? Chalo. Right on. As the temperature increases, the maxima of the curve shifts to shorter wavelength. The maxima of the curve shifts to shorter wavelength. Next point. Several attempts were made to predict the intensity of radiation. As a function of wavelength. To predict the intensity of radiation as a function of wavelength. But no satisfactory explanation could be given. But no satisfactory explanation could be given on the basis of wave theory of light. Explanation could be given on the basis of wave theory of light. Okay? Now you can copy both the diagrams. Continuing. So Max Planck, or Planck's quantum theory, says that now this is something new, 10th standard तक ये कुछ भी नहीं था, is that light is quantized. Let's understand the meaning of the word first. Light is not continuous. For example, let's say lights off कर दिया. If I turn on, so we feel as if this is continuously coming out of the let's say bulb, or let's say when you open a tap of water, so water flows continuously. So it was assumed that even light is like that, it is flowing continuously. But no, Max Planck says that light is quantized. It is made up of small bundle or small packet of energy. So you can imagine that from the light source that we have here, people, in simple terms, we can see that light is coming out in the form of packets. Yes, sir. So light is coming out in the, and yes, between two packets you can say that हाँ एक छोटा सा lag or gap या time है. Each packet here is called as a quanta, or it's also called as a photon. And Max Planck said that this quanta or this photon, excuse me, the energy of this quanta or the energy of this photon is directly proportional to the frequency of the photon, and the energy of this quanta, if it is directly proportional to frequency, it will be inversely proportional to its wavelength. With me? The energy of this quanta is given as E is equal to h nu. Each quanta ka energy is given as E is h nu, where h stands for Planck's constant. The value of Planck's constant is 6.626 in 10 raised to minus 34 joules second. Kabhi-kabhar we take it as 6.63 into 10 raised to minus 34 joules second. In terms of lambda, we can write this as E is equal to hc over lambda. Now this is for one photon. Energy of one photon. If we have n photons, the formula becomes E is equal to nh nu, or E is equal to n into hc over lambda, where n is the number of photons. Anyone did not get that? Every photon for a light of a particular wavelength will have the same energy. So aisa nahi ki one is different than the other. Let's say we're talking about yellow light, so yellow photon. All of them will have the same characteristics. Did you people get that? So sirf likho Planck's quantum theory. No, I'll dictate. Black body radiation. Right. Energy emitted or absorbed, energy is emitted or absorbed by atoms or molecules. By atoms or molecules is discrete slash discontinuous slash quantized. I repeat, discrete, discontinuous, quantized in the form of small energy packets, in the form of small energy packets called quanta or photons. Next slide. The energy of each quanta, is directly proportional to frequency and inversely proportional to wavelength. Is directly proportional to frequency and inversely proportional to wavelength. Directly proportional to frequency. The energy of each quanta is directly proportional to frequency and inversely proportional to wavelength. Next point. Photons travel in vacuum with the speed of light. Photons travel in vacuum with the speed of light. But as the medium changes, their speed changes. As the medium changes, their speed changes. However, frequency remains the same. Next point. Photons travel as waves. Photons travel as waves but are emitted or absorbed. As particles. But are emitted or absorbed as particles. So, when you're not looking at a photon, it behaves as a wave. The moment you start looking at it, it changes itself to a particle. Electrons are also something like that. So when you're not looking at an electron, it is a wave. The moment you look at an electron, it becomes a particle. Why is this as such? ये आगे के part of the chapter में पता चलता है. चलो, please copy this for me. Okay, so let's discuss some questions. What's the first one? People calculate the energy of photon having wavelength 662.6 nanometers. Chalo, give me the formula for the energy of a photon. What's the formula in terms of wavelength? E is equal to hc by lambda. So, how much is Planck's constant h? 6.626 into 10 raised to minus 34. How much is the speed of light, people? 3 into 10 to power 8 meters per second upon. Now, how much is wavelength lambda given? 662.6 nanometers. How can I convert nano into meters? 662.6 into 10 raised to minus 9 meters. Do you see this number and this number looks somewhat similar? तो हम क्या करेंगे? I'll try to bring this to this. So I can write this as 6.626 into 10 raised to minus 7 meters. Anyone who did not get that? क्या किया? Just यहाँ पे shift किया. So 10 raised to minus 9 will become 10 raised to minus 7. So can I substitute that over here as lambda? 6.626 into 10 to power minus 7. Any questions still here? Up कर सकते हैं? This will go away. So we are left with 10 to power minus 34 into 3 into 10 to power 8 upon 10 to power minus 7. Take this upper. So we have 10 to power minus 34 into 3 into 10 to power 8 into 10 to power 7. So 7 plus 8, 15. 15 minus 34, 19. So the total becomes, the unit is joules. Anyone did not get that? What about the second one? What is the unit of frequency given people over there?
Megahertz.
So they've given us that as 400 megahertz. How much is mega?
10 to the 6.
So that becomes 400 into 10 to power 6 hertz, or you can write this like 4 into 10 raised to 8 hertz. And now which formula will we use? E is equal to h into nu. H is 6.626 into 10 raised to minus 34. How much is nu? 4 into 10 to power 8. I think you guys can multiply this for me. कर सकते हैं जल्दी जल्दी. Okay. The question here is calculate wavelength of a photon having energy. Now people, the energy here is given in a different unit. It's 3.1 EV. EV stands for electron volt. So energy of photon is 3.1 EV. We need to convert electron volt to joules. The conversion factor here is given. 1 electron volt is 1.602, so this becomes 1.602 into 10 raised to minus 19 joules. That's the energy of the photon. What do we have to calculate? Wavelength. Formula that we will use is E is equal to hc over lambda. The value of h is 6.626 into 10 raised to minus 34. Speed of light is 3 into 10 to power 8 over, and lambda is what we have to find, and this is the energy, which is 3.1. so lambda, we can write it as 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 over E, and E is 3.1 into 1.602 into 10 raised to minus 19. Solve this and let's find lambda. Detailed calculation and answer is on the board. Last question. I think you people can do as homework. I'll, however, just give you the data. A bulb is rated as 110 watt. You'll use this as energy E. You have to calculate the number of photons. What we're looking for is you have to calculate N of red light. And what is the wavelength given, people? Lambda is 6626 angstrom is 10 to the power minus 10 meters. You will use Planck constant as 6.626 into 10 raised to minus 34. Speed of light as 3 into 10 to power 8. And हमारा formula है E is equal to N into HC by lambda. All the data. E is 110. N is you have to find. H is 6.626 into 10 raised to minus 34. C is 3 into 10 to power 8. And lambda is 6626 into 10 to power minus 10. ठीक है? We stop here for the day. Next class we continue with atomic structure, we'll do different atomic models, and then eventually move on to Bohr's atomic theory. Thank you, people.